Next time you're on a road trip, look out at the horizon. You'll see them standing like white giants, modern wind turbines. They are marvels of engineering, towering hundreds of feet in the air. But if you pay attention, you'll notice something consistent. Whether you are in Texas, Germany, or China, almost every single commercial wind turbine has exactly 3 blades. Not 2, not 4, and definitely not the 20 blades you see on those old rustic farm windmills. Why? Is it just for looks? Or is there a specific rule of physics that makes the number 3 the magic number for harnessing the wind? Today, we're counting down to the perfect number, right here in Simple Things Surprising Histories. To understand why we use 3 blades, we first have to understand what a turbine is actually doing. We tend to think the wind pushes the blades like a fan, but that's not quite right. Turbine blades work like airplane wings. They generate lift. As the wind flows over the curved blade, it creates a pocket of low pressure that pulls the blade forward, making it spin. So you might think more blades means more lift, right? Well, not exactly. If you have too many blades, like those old farm windmills, they create too much resistance or drag. They spin with incredible force, but very slowly. That's great if you're grinding grain or pumping water, which requires heavy torque. But to generate electricity, we don't need heavy lifting, we need speed. We need the turbine to cut through the air efficiently. If you add a 4th or 5th blade, you actually create turbulence. Each blade ends up hitting the messy, broken air left behind by the blade in front of it. To get electricity, fewer blades are actually better. Okay, so if fewer is better to reduce drag, why not 2 blades? It would certainly be cheaper to build. Believe it or not, engineers tried this, but they ran into a massive problem: the wobble. It comes down to stability. When a turbine blade points straight up, the wind is strongest. When it points straight down, the wind is blocked slightly by the tower itself. This is called tower shadow. In a 2-bladed turbine, when one blade is vertical, the other is vertical. You have a sudden, jerky shift in forces twice every rotation. This creates a phenomenon known as gyroscopic precession. Essentially, the turbine wants to wobble, causing massive structural stress. 2-bladed turbines tend to chatter, vibrate, and eventually break. But with 3 blades, the forces are balanced. When one blade is under stress, the other 2 are in positions that smooth out the load. It creates a steady, constant rotation, like a flywheel. There is actually one more reason, and it has nothing to do with physics. It has to do with us. Engineers have actually built 1-bladed turbines. They are incredibly efficient, but they have to spin at terrifying speeds to stay balanced, and they require a heavy counterweight. They're loud, and frankly, they look violent. Visual aesthetics matter. 3 blades spin at a pace that the human eye finds pleasing. It looks calmer and safer. Since these giants have to be placed near towns and highways, public acceptance is huge. A 3-bladed turbine looks like a graceful machine. A 1-bladed turbine looks like a weapon. So, why 3 blades? It is the engineering Goldilocks number. 4 blades create too much drag. 2 blades wobble and break. 1 blade is too noisy and scary. 3 is the perfect compromise between aerodynamic efficiency, structural balance, and cost. It is the simple solution to a complex problem. If you enjoyed this breezy tour through physics, give this video a like and subscribe to Simple Things Surprising Histories for more stories about the world around you. I'll see you in the next one.